All right, so today we're going to talk about Presto on Kafka at Uber scale. Um, so to begin with, so DP already did a long introduction about us. I'm Yupeng, I'm an engineer at Uber. So I lead the real-time data infra. And at Uber, we leverage a lot of open source technologies like um, Kafka, Presto, Flink, Plino, and many others. Yang, do you want to talk about yourself?
Yeah, so as DP mentioned, so I'm a software engineer at Uber, and so I'm mainly focused on building the highly reliable and scalable Kafka ecosystem, and providing Kafka as a service for the entire all the engineers at Uber. Yeah,
Right,
yeah.
thank you.
Hand over to you. Yeah.
Right. So to begin with, like I'm pretty sure people are familiar with Uber, and our mission is to ignite opportunity by setting the world in motion. As you can see, some numbers on the slides. Uber's empowers like a lot of like activity around the world, and we operate at the planet scale, and we have lots of rides and its delivery. In fact, we have many like products, as you can see at the bottom of this slide. And in turn, this also gives like challenges on the data side, um, like on analytics, like data applications, and many others. So in this talk, we want to focus on the streaming aspects, especially the analytics part through Presto. So here's like a 10,000 feet overview of the entire big data stack at Uber. So every day we collect a lot of information from different data producers, like for example, the rider apps, the driver apps, and the many other services. Like every second, there are like tens of thousands of events produced to the Kafka cluster. And we also use Kafka to capture the data changes from databases, like for example, Cassandra, Schema, MySQL, and many others. Um, and look at if you look at the downstream, there are like many different applications. Like for example, we use Flink for streaming processing. We use Pinot for the real-time analytics. And also importantly, we ingest data into our Hadoop-based data lake. And from there, we can perform batch-oriented analytics and run those kind of queries. As I highlighted in this diagram, there are two important components, Kafka and Presto. So Kafka is as you can see, is the data hub. So it aggregate data from different producers and then dispatch to different consumers. It's actually the glue connecting different components, especially the online world and offline world. And Presto is also plays a very important role in the analytical world at Uber. As you can see, the um, we use Presto as a query federation engine. So from Presto, people can query different sources like Hadoop, Pinot. I actually we are working on Presto on Spark, so that we can bring the power of the unified SQL language and much improve the user experience for our data users. And in this talk, we actually make the connection between this most important component in this data stack so that we bring the power of Presto directly query over Kafka. Quickly to introduce about these two key technologies. For Presto, we actually have a really large scale and deployments. I think you probably have seen this more details about Presto from other talks. For example, today we also talk about the deep dive of Presto at Uber. So I will not dive too much into on this part, but just to showcase that the impressive numbers here about the scale. And about Kafka. So Kafka has been the de facto standard for data streaming at Uber for many years. And we have talked about this in various conference, like meetups, to show the Kafka scale. In fact, we have one of the largest Kafka deployments over the world, and empower many different types of use cases and Uber. So today, as I said, we're going to focus on the analytical part. So let's look at this. Like, why Presto for analytics over Kafka, right? So to begin with, I want to introduce like one interesting scenario that actually happened frequently in the Uber production environment. So assume the DevOps team, they develop a new version of the service and they roll this out. And let's say this service is to process some is order payment. And this deployment is out for a few hours, and then the ops receive some of the issues reporting, say, some driver did not get the payment. So you can see this is a pretty serious issue. And the city ops report this to the dev team to look into this urgent problem. So what the devs need to do is that because of the input and output to this application, there are streams. So the first thing first is to look at both the input and output to see if there's really an event with this particular order information is missing. So that can give like quite useful signals on the troubleshooting, right? So the query can run is that like we're going to search for one particular order with this given UID in the Kafka stream. So I'm pretty sure this kind of ask is very common, is very like straightforward analytical requirements. And before we have this Presto Kafka, we only have very limited toolings for this kind of support. Maybe it's possible to do the simple filtering. However, when you want to involve more complex analytical query patterns, people hit frequent challenges on this. So before we dive into on this part, I just want to talk about the alternatives, especially the alternative open source solutions, because for analytics over streams, they are it's pretty hot topic in this domain. Like for example, the people use Flink or Storm or KSQL for the stream processing over the stream. And also like there's like technology like Pinot or Joule ClearHouse to do the real-time analytics. And in fact, both Flink and Pinot are adopted by Uber. So like, why do we need to do this? There are a couple of reasons. One is that both Presto and Kafka are already popular like technologies and then adopted by different organizations, and similarly for Uber. And we believe this is a pretty lightweight solution to reuse the existing deployments so that like we can directly use the already available Presto service to query Kafka. So no onboarding is needed, right? Like for example, if you want to use Druid or Pinot, you probably need to have a onboarding process to ingest from this Kafka topic and build up a table, create an index, and then you can start like to query. But for the Presto on Kafka, as long as you have this Kafka topic available, user can directly query it through the Presto interface. Another importance is about possible correlation with other data sources. So Presto is known for the query federation engine. And today people already use this to query different sources like Hive or MySQL. So with this addition of Kafka sources, it's possible for you to build correlation across data sources, right? So it's possible for you to join a Kafka stream like with a Hive table or with a MySQL table. That's give you much powerful like analytical toolings for different kind of scenarios. But there's also a limitation about this solution. Like first, the current implementation does not have any index on the storage part. So unlike Pinode and Android that can build index, Presto Kafka has to rely on the scanning of the topic and the stream. And that means like this be much slower than the real-time analytics like solutions. The other thing which is different from the streaming processing engine like Flink, that the Presto Kafka is a batch query. So there's no continuous stream processing. Each time you run a query, you get like a batch query result, capturing the snapshot at that moment. So based on the advantage and this limitation, we identify several scenarios that can really get the power of this. Like for example, like frequently people want to do the ad hoc exploration once they have like Kafka stream available. They don't want to go through the expensive onboarding process for ad hoc operations or analytics, right? And the other scenario we found very popular is that like when people are prototyping some streaming applications, like either be a Flink job or a streaming microservices, people need to do certain debugging or prototyping to see if the logic is correct, right? So as example, I show at the bottom, people, for example, to do certain streaming aggregation over a window. And having Presto on Kafka is a very handy tool to validate the logic is correct by this cross-reference between different technologies. So before we move on to this, I want to say, so Presto open source already have a Kafka connector, which was contributed like a couple years ago. And in the rest of talk, we want to deep dive on like why that's not sufficient for us and what kind of improvements that we made over that to meet the unique challenges at a large scale, especially at Uber scale. So I will pass it on to Yang for the rest of this talk.
Yes, thanks, Yupeng. So when we look into the open source Kafka connector, it is functional, but there are a few areas that is not fully fit into a large scale Kafka architecture like what we have at Uber. So let's start with the first part, is the topic and the cluster management. So the open source connector uses the static file to load the Kafka cluster information and the topic list. And it is being loaded during the connector bootstrap phase. Which means whenever we want to add a new topics, we need to restart the connector. At Uber, we have dozens of clusters and tens of thousands of topics. Restarting the connector at every time we add a topic is not very scalable. Same thing apply to the schema management. In the open source, the schema is being loaded through a static folder during the bootstrap phase. But with Uber, we have thousands of schemas, and the user is able to do the schema update through a self-service interface on our internal schema registry. So the open source solution does not fully fit into our needs. And there's no query restriction on the open source connectors. It is fine when you are querying moderate traffic topics. But with Uber, we have large topics that even a topic with a gig per second throughput. So if we don't restrict the query, then the query might take a long time to return a result. It's not good for the user experience, and it's not good for the healthy of Kafka cluster. Same thing for the query quota control. So there's no quota control on the open source. But the thing is like with the popularity of the Presto in Uber, it is possible we have multiple concurrent query happen in the same time, and in which might lead to the possible Kafka cluster degradation. Given the importance of the Kafka cluster at Uber, we just want to avoid this kind of degradation at any cost. Next slide, please. So next, let's take a look at our high-level architecture. So the squares in the red is the improvements we have made. So let's go through the flow very quickly. So user can write the Presto query in the UI. So the query will be sent to the Presto engine directly, and the Presto engine will we will do the query filter during the for the query, and all the query that does not meet the certain criteria will be rejected. But once the query met the criteria, it will be executed inside the Presto engine. And inside Presto engine, we will only have one Kafka connector, which can be talked to multiple Kafka clusters. The Kafka connector will integrate with our internal Kafka cluster management service to get the Kafka cluster metadata and the topic information. And in the Kafka side, we also applied the Quota Control to avoid the potential degradation inside in the cluster, which might caused by the Presto. And when the Presto Kafka Connect get the result from Kafka, it will also talk to our internal schema registry to get the schema information if it presents. And it will use the schema to do the decoding and then return the result to the UI. And next slide. So next, we are going to deep dive into how we made all of this improvement. So the first part is the cluster topic and schema management. As you can see from the figure on the right, the open source connector load the cluster topic and the schema information during the cluster bootstrap phase. So, and also it only supports a single Kafka cluster connection inside a single Kafka connector. So what we want to achieve is a dynamic schema and a Kafka cluster topic information retrieval. And also we want the Kafka connector can be connected into multiple Kafka clusters. So what we did is we actually extract the interface of the Presto table description and also the Kafka cluster management inside the Kafka connector. And then we implement a new strategy that is able to fetch the Kafka cluster topic metadata and schema on demand. By doing this, naturally, we are able to enable the multiple Kafka cluster connection. Also, inside Uber, there are a lot of topics leveraging the Avro decoding. So we also did some improvements on the Avro decoder to make sure it support more complex data types. Next slide, please. So the next part we are going to talk about is the query filter. The reason we are doing query filter are mainly for two purposes. One is we want the query can be returned within a reasonable amount of time. The second is we want to avoid Presto consume a tremendous amount of data from Kafka. So what we did is also two parts. The first part is we enforce the query filter on either partition offset or timestamp field. The reason we are doing this is because these are the only two fields in the Kafka Connect that is able to be pushed down into the Kafka broker. Another thing we did is we restrict the max number of split for each topic partition. By doing so, we are able to restrict the number of messages that is consumed from Kafka. So all this validation are done before the query being sent to the Presto workers. So this means if the query does not meet this criteria, then the query will not be executed, and no Kafka consumption will be happened. And the user will get a error says the query does not meet the criteria. Next slide, please. Yeah, the last part we are talking about is the quota control. So the reason we are doing this is, as we mentioned before, Kafka is a very important service at Uber. And Presto is also a very popular service at Uber. So it's possible there are multiple concurrent Presto query at the same time querying the same cluster. And the cluster also serving a very important online traffic. So it is possible that all these resources are just get all this query that happen at the same time, which overwhelms the Kafka cluster. So what we want to do is we want to limit the resources that can be used by the Presto. So the best way to do it is to apply a global quota on the Presto cluster. What we decided is we want to do it on the Kafka side. And one of the most common solution on doing quota in Kafka is to set a consumer quota on a client ID. But the Presto connector, actually use the query ID as part of the Kafka client ID. So we cannot apply quota because it is dynamic. So what we did is we actually use the static Kafka client ID for the entire Presto cluster. So they will be subject to a global quota. This will protect the Kafka cluster from the concurrent consumption. But it also with some limitation, like the concurrent query will take longer time to return. But it is a balance we have to make. And with the query filter we mentioned before, most of the queries can be returned within a reasonable amount of time, and we don't observe any user impact with all these improvements. Next slide, please. Yeah, so we have done all these improvements in-house, but we also want the open source community to be benefit from all these improvements we have made. So we have merged several diffs into the open source upstream, and we have a few more in progress, and also a few more to be merged. Next slide, please. Yeah, in the last, let's take a look at a quick demo. So as Yupeng mentioned, a very common use case, like someone wants to search a topic with a certain UID. So with Presto on Kafka, you can easily write a Presto query, which is a SQL-like query, and then you can quickly get a result. And next, we should go to Q&A. Yeah. Next slide, please. Yeah. Thank you. Yeah.
All right. Thank you.
I don't see any questions. So
great session, Yupeng and Yang. Very nice job on explaining more about the connector, how it actually works. And also thank you for all the contributions to open source. That's one of the big reasons why we're here. Hi, Hamid. Question for you folks. Kafka is also a query engine. I think you talked a little bit about that in the beginning, about KSQL and others. What was the benefit that you got from using Presto on Kafka instead of using the other approaches?
Right. That's a good question. So we covered this a bit in the beginning of slide to talk about alternative like KSQL. One reason is that for large organization like Uber, we build different like platforms, right? So if you look at on the query part, Presto is kind of the de facto query engine that used by like almost all the users inside Uber. And we build a lot of ecosystem around this, right? Like as Yang showed in the demo, we have a very nice UI, the query builder, on visualizing the result, and also how to export results back and integration with other different like services. So, and then to us, it makes more sense to do a consolidation and improve the existing platform, such as Presto, other than introduce another stack app technology like KCQ. And also for KCQ, that is a little bit like, I would say, similar to Flink other than Presto, as it's more like a continuously like update on the core result. So there's some like subtle differences between the solutions. Not even to mention that another key reason is to join the Kafka stream with other data sources, which is very powerful in our use cases. Thanks for the question.
Are you actually doing joins across HDFS and Kafka, or is this mostly just for querying Kafka streams itself, topics themselves?
Yes, we do see queries that are joining Kafka stream with the other data warehouse, other data sourcing data warehouse. So.
Got it. And are these use cases, is that often, or are there some use cases where you really want to have a real-time view of historical and the most current data? Is there a time window where that is a common use case?
So I can give you some motivating example, right, that I have seen. People use Kafka to capture the data stream, like from the data changes from the databases, right? So, and as a like troubleshooting or for investigation, people want to know, hey, this is my database snapshot, for example, in MySQL. Has the right change propagated through Kafka to other sources? Has that triggered the actions? So with Presto Kafka, we can build this correlation and identify, yes, we do see an event that corresponding to this particular record in a database, right? So that's one, I think, example that demonstrates the power of this.
All right. Well, thank you so much again for the presentation, Yupeng and Yang. And folks, the next one up is Presto at Tencent. And so wrapping up this session in this room, let's move over to the other room in 5 minutes. Thanks, everyone.
Thank you.
Cheers.
Thanks.
Bye.
Thank you.
Bye.